Hello, and welcome to the Dustin Eric Podcast Show, brought to you by Mimosa Networks. Hi, I'm Dustin.
I'm Eric.
And today we're on part 2 of episode 11, Site Planning, Installation Planning, and Interference. So, last episode we discussed a high view of site planning, installation planning, interference. We mentioned some keywords, harmonics and DFS. So if you guys want to talk about harmonics real quick, kind of explain what that means.
Yeah, it's a small musical instrument. No, just kidding. Well, harmonics are essentially just that. It's signals that are within a certain frequency spread. So what happens is you have a harmonic of, say, 2.4 gigahertz. So the next harmonic could be in 4.8. So just take the signal or the frequency number and then just double it. Either double it or subtract it and
cut it in half.
Cut it in half, and you will see a harmonic literally showing up on the spectrum analyzer.
So a quick question here. So if I'm at 900 megahertz, I double it to 1800.
Yep.
Mm-hmm.
I double that again to 36,
Yep.
or do I go to 27?
It's all dependent upon the quality of the transmitter. A low-quality transmitter will most often have multiple harmonics, whereas a higher-quality transmitter will not have as many. So it really depends on that.
So you're taking the fundamental frequency and, again, doubling it for a second, third, fourth order harmonic. So they're just multiples of the primary frequency, right? The operating frequency, or halves thereof.
So I know a lot of customers ask what DFS is, and they don't know what that means. So can we talk a little bit about what DFS stands for, the acronym, and what it means, and why they have to deal with it?
Well, DFS is a frequency, stands for dynamic frequency selection, and as a wireless operator, you are actually considered a secondary operator. So the radar usage on DFS channels has a primary operation within that frequency. So if you're near a time Doppler weather radar, military site, or aviation location, either airplanes above or an airport, they have primary use of that frequency. If you are a wireless operator, you kind of get the back seat to those frequencies, meaning that if there is a frequency detected on the radar, we'll say 5600 time Doppler weather radar, and you are occupying that channel, what will happen is, by law, under FCC, you have to immediately vacate that channel. And so it's really important to consider that when you are trying to operate a wireless network, that you will lose connectivity during that time of what we call a radar hit. And that can definitely cause troubles if your customer is expecting to have service during that time.
So I have a question for the whole group here. So when planning a network out and choosing your spectrum, would you want your backhauls to be on DFS, or would you want your point-to-multipoint system to be on DFS because of the shorter shot?
It's probably best not to have your backhauls on DFS. If you are limited with the amount of frequencies available and you have a dual radio like a B5 or a B5C, one of the recommendations we have is to choose one DFS channel and then choose one non-DFS channel. In the rare event that a DFS radar hit occurs, you're not going to lose the entire link. You'll see a drop in service as far as your throughput, but you will not lose total connectivity.
What about you, Art? What would you do? Would you do DFS on your backhauls, or would you just do that on point-to-multipoint?
So if possible, in either case, you don't want either situation, because in one case you lose clients, or in another case you lose your main link. So if you can avoid it, if you can actually use non-DFS for both, that's the ideal. So with our product, if there's a radar hit, the intent is basically not to lose a connection, so it'll drop you to a non-DFS channel. Mm-hmm. But if your non-DFS channel is completely, if you've limited, if you basically restricted that channel, or if it's completely inundated with noise, then your performance is going to drop anyway.
Would you consider reducing bandwidth as well if it's you're getting pushed around, it's really crowded?
So if you can, what we suggest suggest to our customers is if you can use a non-DFS channel, but you can only use in 1x40. That's still better off than using a noisy 1x80 channel where you're going to lose a lot of performance.
Okay, so because we're talking about DFS channels, there's several terms out there: Uni 1, Uni 2, Uni 3, UNNI -1, 2, and 3, which kind of correspond with the parts of the 5 gig band. Do you guys want to talk about what those mean and which frequencies are in which band?
And power limitations.
And power limitations.
Sure. I mean, we can start with your DFS channels really fall into Uni 2, and your ERP limits so usually those frequencies have less interference, less noise, because less users are on them, because you'll basically jump from one channel to the next with dynamic frequency selection. But the downside is you are limited in power when you hit those channels. So it's a trade-off. Either you use a non-DFS channel, which is Uni 1 or Uni 3, or you select the Uni 2 channel with less noise but also less power, which will limit your performance as well.
Where can I find a 5 gig spectrum with the Uni 1 2 layouts at DFS? Mimosa.
If you go to our help site, just type in the ERP or ERP limits. You'll definitely pull up under backhaul. So help.mimosa.co under backhaul and type in ERP.
So backing up here just a little bit back to our design tool. When you're designing an actual radio link, does the design tool take into account what frequency you're wanting to use, and does that back the power off on the overall result of what you're expecting?
Yeah, you can actually do that through the link settings on the design tool. The beauty of the design tool is that you can adjust it pretty much to what you want. We've purposely done that so that customers that are in different countries can adjust it accordingly. So keep that in mind when you do a design, that you just don't use the default settings, but in fact go in and tweak each of the values, whether it's TX power or the channel, so forth. So it's going to take a little foreknowledge as far as what the regulations are for the country that you're operating in. But go into link settings and do that so that you can design a link based on the location and just not based off of the default settings there.
Good point, Jeff. Because under licensed and unlicensed, there's different ERP limitations. So
that's right.
Yep.
Also, I don't think we covered this, but rain fade. We want to take rain fade or rain fade zones into account when we're designing our link. The cool thing is the design tool kind of already takes that into account, but you can play with your link settings and increase or decrease rain fade as you see fit to help give you a better estimate on how well your link will survive during heavy rainfall.
Does it default when I go in there? Does it have a default for my geographic location already?
It does.
Approximate percentage of
Yes.
rain. Yeah.
That's pretty cool.
So for those of you who are in the south or up north where it rains a lot, the tool pretty much already knows the average rainfall. But again, you can max that out and see exactly how you can perform. Especially important for the B24 or any higher frequency radios that will fade or drop out completely in rain depending on the distance of your link. Do you want to talk about your B24 on the tower competing with other space?
Yeah, well, since you're talking about B24, one of the things that we've seen is folks using the B24s next to competing technologies, other manufacturer radios. The benefit of the B24 with the GPS sync is that you can co-locate with other Mimosa radios. The downside of it is that other technologies or other competing manufacturers do not use or share the same technologies that we do. So one of the challenges that you can have when designing or planning your network is to make sure that you understand what the tower has on it. If there's other 24 gigahertz systems or 10 or 11 gigahertz systems, or in this case even 5 gigahertz systems that you take into consideration that you may not have full reign of the frequencies that you would like. So again, I can't stress enough that it's very important to know the RF environment prior to start hanging equipment onto the tower. So
Great
again,
picture. Yeah. Look at
like
that.
you see in this picture here, that you're going to have to share frequencies with other manufacturer radios.
So you have physical space on this tower and the tower next to it, but you might not have space in the spectrum to actually deploy it.
That's right.
Of course, you can't really tell what these are from the picture, but that's why you have to go visit the site, probably climb or take your drone up, get vendor names and part numbers, and try and figure out what that is, or use your spectrum analyzer to see exactly what you have on the tower.
You can also request for some of these tower sites from the property or site manager the layout and who has the real estate on the tower itself, and they'll usually have different frequencies or different spectrums and who's at X heights. They'll have the height layouts, the integrated radios or separate antenna and radio layouts for each one. Sometimes they're updated, sometimes they're not current, but it'll give you an idea who's living on the tower and where they're operating at.
Just to have an idea, if nobody does this, but this would be great if on the back of the antenna, somebody actually wrote which company's actually installed this, or who to contact if you want to, if you have issues or questions.
That would be nice.
Some companies do that, but not a lot do.
Hey, and Mimosa puts an orange M as a nice big flag on the front, so hopefully that's helping some folks that are dialing in and say, hey, Mimosa, you've got a couple of radios on our tower. Can we squeeze in a couple for our own?
But they'll call us and not the actual
Right.
installer, so we will have no.
Since we're talking about
who's actually done the work.
since we're talking about
Right.
co-location, another thing that we see a lot of is customers where they install the equipment on the tower, and the antenna from the competing technology or just another vendor, or it can even be our stuff, where it's shining into the other antenna. So antenna radiation pattern overlap is very important to consider, that your antennas are not self-interfering with creating SP errors or some of the other issues that you can have where signal is actually corrupting, or in this case, another radio is corrupting the signal of another radio. So be sure that your antennas are not overlapping as far as the radiation patterns. We like to see no less than 80% overlap.
So one last thing here to talk about is different antennas have different what's called front to back ratios,
Right.
and even front to side ratios. So it's best to try and get an antenna that has a really high front to back ratio where you're not causing interference for if you're co-located antennas with yourself or with other people that are located around you on the tower as well. So there's antenna manufacturers out there who make higher front to back ratio antennas than others, but usually you're going to spend a little more money for the better quality antenna. So it depends on the spectrum and what you're trying to do, but it's always best to try to be considerate for the other folks that are on that tower as well.
Sure. We have a really great document online, co-location document, really geared towards this subject that it would be a good reference document if you haven't read it already.
All right, guys. So we'll go ahead and end this show here. I just want to let our listeners and viewers know that Mimosa is now offering training for this type of stuff. Our first training will be at Wispapalooza in Las Vegas this year, 2018. So feel free to sign up for that. You can go to our website and do that, and get some hands-on training and some training on backhaul and our access products. Actually, Jeff and I will be running that training, so it'll be good to see you guys there if you are interested in doing that. But otherwise, that's it. The show covered site planning, installation planning, and interference. Two-part. Make sure you watch the first part. It's important to watch them both together. So anyway, we'll see you on the next episode of our show.
And we'll see you at the live podcast at Wispapalooza 2018,
Live.
October 9th.
Anyway,
He'll be fashionably early there.
I'll be there.
We'll be at the
We'll
Mimosa
there.
party on Monday,
Yeah.
Wispapalooza Monday. So our next show will be about antenna selection and alignment. So they'll talk more about the front to back ratios and things like that. So, all right, guys. See you next time. Thanks for tuning in. Please hit the subscribe or follow button to stay up to date with our latest podcast, which will be available on YouTube, iTunes, Google Play, and SoundCloud.